So hello and good evening everyone, whoever has joined us on this live session. Okay, I welcome you all to ODA class. Welcome everyone, and again a very good evening. So just to let you know, in today's class we are going to study about polynomials. Okay, now this topic has a lot of importance. Okay, has been introduced to you in class 9 and you are going to study it till class 12. So this is something that is really important, and whatever we are going to discuss today is going to be absolute basics of polynomials. Okay, so just keep following. Okay, the explanation will be concise and I hope you people understand whatever is being taught. Okay, but before we start, let me just give you my introduction. And so my name is Satyam. I am one of the master teacher of mathematics here at ODA. Okay, I've done my BTech from NIT Warangal and have more than 6 years of teaching experience. Okay, now so before we get into the technicalities, okay, before we understand what polynomials are, first of all, let us understand the flow of the content. So what all things are we going to study? Okay, in what order? Okay, so firstly we are going to introduce what polynomials are, then what polynomial expressions are. Okay, now this polynomial expression thing has already been taught to you in your class 9. Okay, but we'll just touch upon this and then we'll move ahead. Okay, now the next 3 topics, these are really important with respect to your board exams. Okay, so I expect all of you to be very attentive and try to understand whatever is going to be taught. Okay, so then we are going to study about the roots of a polynomial equation, how to find roots of polynomial equation for a 1-degree polynomial and a 2-degree polynomial, then relation between the roots and the coefficients. Okay, now this is, we can mark this with a star because for sure you are going to get a question out of this, 100%. Okay, without any doubt, pakka there will be a question on this. Okay, and then we are going to study about graphs of polynomials. Okay, so chalo, let us begin. Okay, now for introduction, we are going to introduce it in quite some detail, so that, because many students are always of the opinion, why are we studying this rather than simply studying. So this is just not for the sake of marks. Okay, please try to understand. Okay, so very crudely speaking, so without giving the mathematical definition of what polynomials are, if I have to define it in words, okay, so then I would just say this, that polynomials are mathematical expressions. Polynomials are mathematical expressions that allow us to express the interdependence of 2 or more variables with each other. Okay, and of course all polynomials are algebraic expressions. Okay, so polynomials are a certain class of algebraic expressions and we are going to formally define it in the next slide. Okay, let us first of all talk about what does this first point mean. Okay, what do we mean by that polynomials are mathematical expressions that allow us to express the interdependence of 2 variables. For this, let me take a very famous equation from physics that all of you must be aware of. Okay, and that is, we all know that when a body is traveling, okay, so let's say there is a block that has started its motion with some initial velocity which I am calling as u. Okay, and it has some constant acceleration, fixed acceleration. Okay, now, and that we are supposing as a. So a is the fixed acceleration here. Okay, now as this body is in motion, the velocity of this body is going to increase. I hope everybody does realize this. Okay, now the velocity at any instant time t is given by this relation. Now this shouldn't be new to you, that v is equal to u plus at. Okay, now what does this relation tell us? So let us choose a value for u and a so that you will be able to understand this better. So let's say the initial velocity is some 10 meter per second and let's say the acceleration is some 9 meter per second square. Okay, now for this chosen initial velocity and acceleration, the expression for the final velocity can now be written as 10 plus 9 times t. Now from here it's clear that as I start putting different values of time t, we are going to get the velocity of the body at that particular instant t. Okay, so let us play around with this equation a bit. Okay, let me choose a value of t as, let's say t is equal to 1 second. Now if I wish to write the velocity of this body at t is equal to 1, then you are going to put this value of t over here. So that is 10 plus 9 and that will be 19 meter per second. Very well. Now if somebody says, okay, find me the velocity at t is equal to 2, again same story again. Okay, so somebody will put t as 2 over here and then we are going to get 10 plus 9 times 2. So that becomes 10 plus 18 and that would come out to be 28 meter per second. Okay, Now just try to compare this, what the thing that we are doing right now with this first line that is written. Okay, so let me just sort it out for you. Okay, so this variable v, so of course velocity is changing with time, so it is a variable, and of course time is also changing, it never stands still, so time is a variable. And this is a relation that is expressing the dependence of time with the final velocity of the body. Okay, and this expression, for your knowledge, is a polynomial. Okay, this is a polynomial. Another very easy example to understand would be another second equation of motion that we study. Okay, s is equal to ut plus half at square. Okay, now this is also a polynomial, though I am not going into a lot of detail what kind of polynomial this is and how are you going to find the distance, but you can understand, if I fix an initial velocity, if I fix an acceleration, then the distance that this body is going to travel will be given by this expression. And it shouldn't be a shock for you to know that this is also a polynomial expression. Okay, so I hope it's clear that polynomials actually act as a way, or it's a tool that expresses the dependence of a variable with respect to some another variable. Okay, and one more point that I would like to clear out here. Okay, so in these equations, okay, time is acting as input, so you input the value of time inside this. As you input time, the velocity in this first equation and the distance in this second equation is nothing but the output. Okay, I hope this point is clear. If this is clear, then the formal definition of polynomial should be really easy to understand. That is the exact mathematical definition, that how do we define it. Okay, so moving ahead, let's try to understand how do we define polynomials mathematically. Okay, sorry. Now, so this scary looking expression is how polynomials are defined. Okay, so let me just read it out for you, and then we will try to understand what we mean from here. Okay, so an expression of this type, okay, so an x to the power n plus an minus 1 x to the power n minus 1 plus an minus 2 x to the power n minus 2, so on up till a naught. Okay, wherein all these values an minus 1, an minus 2 and a naught, these are all constants, real numbers. Okay, and x here is acting as a variable. Okay, see, while studying mathematics, it actually we are not concerned about what the physical significance of the problem is. It was just for introduction that I gave you a problem for physics, so that you can correlate with the real life that what you are studying is actually useful. Okay, so in mathematics, generally whenever we have to express a variable, our chosen variable is going to be x, y, maybe if we are talking about more than two variables, we can talk about z and so on. Okay, so this is a polynomial in the variable x. Okay, so this is a polynomial that contains only one variable. Okay, here again, all these powers on the variable, so if you are noticing, every power on the variable over here has to be a non-negative integer. Okay, for example, if I write something like this, x to the power minus 1 plus 1, so is this a polynomial? No, this is not a polynomial. Okay, because the power on the variable x over here is a negative integer. Likewise, if somebody wants to write x to the power 1 by 2, so any kind of algebraic term that contains x to the power 1 by 2 will not be treated as a polynomial. Okay, so there is a certain criteria that a particular algebraic expression must qualify for it to be treated as a polynomial, and that is that the variable must have a non-negative integral power on it. Okay, and the coefficients, so what do we mean by coefficients? So if you see over here, these numbers that I have circled down, an minus 1, an minus 2, so these are termed as coefficients of these powers. So for example, we will say that the coefficient of x to the power n here, the coefficient of x to the power n here is going to be an, coefficient of x to the power n minus 1 is an minus 1, coefficient of x to the power n minus 2 is an minus 2, and so on. Okay, so I think it should be clear now what we mean by a polynomial. So a polynomial is something, it's an algebraic expression in some variable where the power on the variable has to be a non-negative integral power. Okay, now many a times straight away the expression will not look like this, but after some manipulation we can maybe bring it out to be like this. Okay, so we'll do a question based on that as well. Okay, now one thing again, selection of a polynomial of a particular variable. So let's say if in a question you are faced and we are talking about a cubic polynomial. Okay, now a cubic polynomial will be a polynomial wherein the highest power on the variable x is going to be 3. Okay, so if you have x to the power 3 in some expression and where 3 is this highest power occurring, then we will say that this polynomial is a cubic polynomial. Okay. Now a cubic polynomial for sure can contain terms having lower powers as well. Okay. So it can look like this. So we can have a term which has x square, we can have a term which has power 1, and we can have a constant. But a cubic polynomial will not have an x to the power 4 over there. Okay, because then it's no more a cubic. Now what we will call this equation will be based on this power 4. Okay, so this highest power on the variable plays a big role in how we term a polynomial. Okay, so it's called the degree of a polynomial. Okay, so as long as the highest power is 1, this polynomial will be called as a linear polynomial. Okay, if the highest power is in a polynomial is 2, it will be a quadratic polynomial, or we will say a second degree polynomial. Okay, but it has a mathematical term, and this is what will be mostly used. Okay, so it will be a quadratic polynomial if the highest power on the variable comes out to be 2. Likewise, highest power on 3 is going to be called as a cubic polynomial, or we can say a third degree polynomial. Okay, and henceforth this lingo follows. So if you have a power 4, it will be a biquadratic, or we can call it a fourth degree polynomial, and so on. But as like in class 10th, hardly you will find a polynomial beyond power 3. Okay, so please do remember these words. If the highest power in a polynomial is 1, we will be calling it as a linear polynomial. If it is power 2, then we will be calling it as a quadratic polynomial, and if it is power 3, then it is going to be a cubic polynomial. Okay, and how a cubic polynomial is going to look like, I think it should be clear. So a general cubic polynomial, you can take it like this. It will be ax cubed plus bx square plus cx plus d. Okay, because see, if it is cubic, we can be sure of one fact, that the highest power is 3, but it's quite possible that the lower powers of x can be there. Okay, so it's always safe to assume it like this. Okay, if x square is not there, obviously the value of b will be 0, and so on. Okay, I hope this point should be clear. Okay, moving ahead, so let's solve a few questions. Okay, now these are pretty simple. So we have to decide that among the written expressions, so there are 3 expressions written in front of you, we need to decide which amongst these are polynomials. Okay, let's come to the first one. Now this first expression, what is written over here is 3x square minus 2x plus 6. Now straight away one can have a look at this and say, yeah, this is a polynomial. Reason being that the variable wherever it exists only contains powers which are non-negative integers. So power on x here is 2, power on x here is 1, and here there is a constant 6. So yes, this is a polynomial. Okay, what is the degree of this polynomial? So degree will be 2. So this will be a quadratic polynomial. Do remember, degree is nothing but the highest power that occurs on the variable. Let's come to the second one. Okay, second one says 3x square minus 2x plus 6 upon x. Okay, now if someone opens this up, I mean like separates the terms and writes, so we can write this as 3x square upon x minus x upon x plus 6 upon x, which can be written as 3x minus 1 plus 6 by x. Okay, now because this term 6 by x is present over here, okay, the power on x in this case is minus 1, which again is not a non-negative integer. So our second question cannot be treated as a polynomial, and this is not a polynomial, do remember. Now the third one, a first look at this third problem tells us, nah, this cannot be a polynomial, because how do we define polynomials? We say that everywhere the power on x has to be a non-negative integer. Now when you look at it, everywhere the power on x is a fraction. Okay, so the way the question has been framed, it doesn't look like a polynomial. But again, before you decide, do make sure that if we can manipulate this expression, if some cancellation is possible, if we can cancel out a few terms and then maybe we can get a polynomial, then yes, we will treat it as a polynomial. Okay, now one can look over here that you can bring out x to the power 1 by 2 common from every term that is there in the numerator. Every term that is there in the numerator, x to the power 1 by 2 can be taken common, and once you take it common, you are going to get inside x cube plus x square plus x plus 1. Okay, now these are things that have been taught to you in class 8, how to take out factors common out of a polynomial term or an algebraic expression and so on. Okay, so we are not going to waste a lot of time in discussing why this comes out to be this. Okay, Now x to the power 1 by 2, x to the power 1 by 2 can be cancelled. Here we must mention a condition that x is not 0, so that this expression is defined. Okay. Now if x is non-zero, then x to the power 1 by 2 and x to the power 1 by 2 can be cancelled to give us x cube plus x square plus x plus 1, and this does look recognizable. This is a polynomial, yes. So please be wary of the fact, and these are kind of questions that can come in your exam, okay, and this can be asked in your board exam as well, okay. So before you decide, please do make sure that if there is any cancellation possible, we do take care of that, and then we decide whether this given expression is a polynomial or not, okay. Simply by looking at fractional powers and these, do not decide it. If cancellation is possible, please do that, and then you have to decide. I hope this example is clear, okay. So we have taken three different kinds of example, one straight away looking like a polynomial, one which is very easy to decide, not a polynomial, and one where some manipulation was involved, and after this manipulation you can decide whether this is a polynomial or not, okay. Next, let's understand a few notations that we are going to use as we study this chapter, okay. Now, so a polynomial in variable x will generally be denoted as p of x. So p to represent polynomial, okay. In bracket this x means, so this is a polynomial in the variable x, okay. So of course a polynomial will be it will be made up of some variable, right? So p of x means a polynomial in variable x, okay. Next, the set of outputs that a polynomial gives for different input values is collectively represented by the variable y. Now it should be clear. So when I took that example of velocity time and distance time, there I told you that a polynomial takes input, okay, and provides you output, as simple as that, okay. So let's say I take a polynomial which I am calling as p of x, which in this case I am taking, let's say I take a quadratic polynomial which is x square plus 1, okay. Now as you input the value of x over here, okay, so when you put x as 1, so put x as 1 everywhere, okay, so you get p of 1 is 1 square plus 1, and this value comes out to be 2, okay. So verbally, if I have to denote this data, if I have to tell someone verbally about this, I'll be saying there is a polynomial p of x square plus 1, wherein if you put x as 1, you get 2, okay. So when x is equal to 1 is input, then output is 2. Likewise, if x is equal to 0 is input, then output is 1, and so on, okay. So for every chosen input, there will exist an output, and all these output collectively we represent by variable y, okay. Of course, if the input is variable, then the outputs are also going to be variables, okay. So remember, y is a variable to represent the output of the polynomial. And finally, the last notation to understand is that the value of a polynomial at any input value x is equal to alpha will be represented by p of alpha, okay. So what we mean to say here is that if you have a polynomial like this, let's say x square plus 1. Now I said, right, put x is equal to 1 as input, so you get 2 as output. So instead of saying this, that for x is equal to 1 as input, the output is 2, one can simply write p of 1 is 2, and this entire expression will be understood. So this means for p of x, when x acts as input, then output is 2, okay. Likewise, if I say that p of 0 is 1, so that means in this polynomial p of x, which in our case is x square plus 1, if x is equal to 0 is chosen as input, then output is 1. So do remember these things, because as we progress, we are not going to say everything in detail. We are going to take help of these notations. So one must be clear with respect to what a particular notation implies, okay. So p of alpha is equal to some number, let's say k. This simply means in a polynomial p of x, x is equal to alpha is being put as an input, and the output is k. Fine. Once you have a clear understanding of this, then we can move ahead to, let's say, solve a particular question, okay. Now again, this question is quite simple. Now here we are saying that p of x is equal to 3x minus 2. So p of x is a polynomial which is a linear polynomial, and that is 3x minus 2. Similarly, q of x is a polynomial which is a quadratic polynomial, and that is kx square minus 2x plus 6, okay. Now we have been given a relation over here that if p of 1 is equal to q of minus 1, determine the value of k. Now what do we mean by p of 1? If you have understood whatever I just told in the previous slide, one must be very clear about the fact that p of 1 simply means in place of x, wherever you find in the polynomial p of x, put x is equal to 1. If you put x is equal to 1, this will turn out to be 3 times 1 minus 2, and that is how much? that is 1. Similarly, q of minus 1. So in place of x, what are you going to put? Minus 1. So let's substitute that. So minus 1 ka square minus 2 times minus 1 plus 6. Okay, now this will become k plus 8, because minus of minus is going to become plus. So 6 plus 2 is going to be 8. Now the question tells us that these two values are same. So let's equate them. So k plus 8 is equal to 1. That implies k is 1 minus 8, which is minus 7. So this is our desired value of k. So this is quite a simple question, okay. And again, a lot of questions in your NCERT are based on this principle. So if the understanding of this notation is clear to its core, then all the questions can be dealt really easily, okay. Chaliye, let us move ahead to the next thing, okay. Now let's talk about equations. So till now I never used the word equation up till now, okay. It's all about expressions. First of all, let's understand what an equation is. Now this term shouldn't be new to anyone, okay. Now equation obviously contains two sides, okay, namely left hand side and right hand side, and you equate them. So you say that, for example, let's say if I take a polynomial p of x and I equate it to some value, let's say I equate it to 0, or I can equate it to 1 or to whatever value I want to, or somebody can say equate it to some other polynomial. So each of these mathematical statements that I have formed over here, these will be all considered as equations, okay. And because these are equations that consist of polynomials, so these are polynomial equations, okay. Now whenever an equation comes, then obviously with an equation what we want to do is we want to solve an equation. So let's first of all understand what do we mean by solving an equation, okay. Now let's say I take an equation which is very simply x plus 3 equal to 5, okay. Now this equation has a left hand side and a right hand side. My left hand side consists of the variable x and my right hand side consists of a constant 5, okay. So if I am supposed to solve this equation, in a way I am interested in knowing a value of x. I want to find a value of x for which the expression x plus 3, the polynomial expression x plus 3 assumes a value 5, okay. This is what it means if converted to words. If spoken verbally, this is what we are doing, okay. But mathematically the process is much easier, okay. All you have to do is shift 3 to that side, you get 5 minus 3, which is 2, okay. And this is my solution. X is equal to 2 is a solution of what? It is a solution of the polynomial equation x plus 3 equal to 5, okay. And you can verify it. If you put x is equal to 2 back in this equation, if one puts x is equal to 2 back in this equation, you do get 2 plus 3, and the left hand side and right hand side are equal, okay. So solving a equation, and in general a polynomial equation over here, because we are interested in polynomials as for now, is looking for the variable x which makes left hand side and right hand side same, okay. So this is what we are going to do. Now solving a linear equation is something that is really easy. You people have been doing it, I think, for at least 2 years now, when you were solving simple equations, okay. We also know how to solve two linear equations in two variables, okay. Let's talk about quadratic equations for a moment. So let me just erase this part. So as I erase this, now try to understand this. Let's say if I write an equation like this, x square plus 3x plus 2, and let's equate it to something. Let's equate it to another polynomial this time around. So let's equate it to x minus 2, okay. Again, so we are looking for values of x for which this polynomial x square plus 3x plus 2 can be equal to x minus 2. Now solving this, now one can rearrange this polynomial. So you can bring this x minus 2 to this side to combine and make this equation as x square plus 2x plus 4 is equal to 0, okay. Now we are interested in, now the question can be again reinterpreted as find a value of x for which x square plus 2x plus 4 will be equal to 0, okay. Now whether a solution exists or not, we will see later, okay. And those who have done the chapter of quadratic equation might be knowing that in this case a solution is not going to exist. There is no value of x for which x square plus 2x plus 4 can be equal to 0, okay. But this is not what we are concerned with at the moment, okay. So the important point to understand here is that given any polynomial equation, okay, you can rearrange terms to get something like this: p of x equal to 0, okay, p of x equal to 0. Now those value of x that will make this equation true are called as the roots of the polynomial. Okay, so roots of any polynomial are nothing but, given a polynomial p of x, we are looking for those values of x for which, let's say that value of x is alpha. If p of alpha is 0, we will say x is equal to alpha is a root of the equation. Okay, fine. I hope this point is clear. Okay, do remember that a polynomial, solving this equation and solving this equation is the same, but the root of x square plus 3x plus 2 and the root of x square plus 2x plus 4 are two different things. Okay, they are not the same thing. It's just that the given equation, the equation written first, this particular equation where I am putting a star right now, this can be converted into this, okay, by manipulation. Okay, but we will not say that the root of this equation and the root of x square plus 3x plus 2 is same, or the root of the second equation and the root of x minus 2 is same. No, okay, that will be two different things. Okay, so again we have already talked about this, that the values of x for which p of x is 0 is true are known as roots. Okay, now we will be considering roots of two types of polynomials, namely the polynomial x, the linear polynomial and the quadratic polynomial. Okay, just a moment, I think the video is getting delayed. What happened to this? Really sorry for this break in video. Okay, yeah, just 1 minute, people. 1 minute. Everything is correct. Okay, yeah, I hope the video is clear now. There's a lot of, forgive me for the lag. Okay, just try to follow with whatever is being spoken. Okay, if you're following whatever is being taught, everything should be fine. Okay, now so let's try to now learn how to find roots of a linear polynomial and a quadratic polynomial. Okay, now for a linear polynomial, finding roots is a child's play. Okay, we all know how to do it. Okay, now given a linear polynomial, let's say of the type ax plus b is equal to 0, the roots of this polynomial will be written as x is equal to minus b by a. How do you get it? You simply shift this b to right hand side, so ax becomes minus b and this becomes minus b by a. Okay, next, and this way you can find root of any linear polynomial. Okay, finding root of a linear polynomial is quite simple. So for example, just let me give you an example. If I have to find root of 2x plus 3 is equal to 0, so that would turn out to be minus 3 upon 2, as simple as that. Okay, now let's talk about a quadratic equation. Okay, now there exist multiple ways to find roots of a quadratic. Okay, the easiest, I hope you people are aware of it. Okay, that is the middle term factorization. So for instance, let me show it to you through an example. Okay, because doing it in terms of variable like constant ABC will be a very tedious task. So let's say I have a quadratic like this, x square plus 3x plus 2 equated to 0. Okay, now the idea is that this quadratic equation is going to have two roots. Okay, one thing that I forgot to tell. Okay, now a polynomial of degree n cannot have more than n real roots. Okay, it cannot have more than n real roots. Now in case of a quadratic, so we will say either there is going to be two real roots or no real roots. Okay, now if the roots are real, if the two roots are real, then what will happen is you will be able to factorize this quadratic as a product of two linear factors. Every time if a quadratic has two real roots, we will always be able to factorize it as a product of two linear factors. Okay, now the way to do so is what we call as the middle term factorization. Okay, though we can do it using the quadratic formula also, which I will just discuss very shortly. Okay, now we are going to write this 3. So the idea is to break this real number, the coefficient of x, as a product of the coefficient of the constant and the coefficient of x square. Okay, again I'll repeat, the idea is to break the coefficient of x, okay, in terms of, or write it in such a way so that the two numbers, so when you break it, obviously you are going to break it in two numbers. Okay, so let's say you have to break 3 in two numbers. Let's call those numbers as alpha comma beta, such that alpha plus beta should be equal to the product of these two numbers, that is the constant 1 into 2 over here, like that. Okay, just a moment, wait, sorry. Yeah, sure. Just a moment. Yeah, okay. Now try to understand how to do this. Okay, so if you can write this 3 as 2x plus x over here, okay, plus 2, so this will be equal to 0. Okay, now from these two terms one can take x common. From these two terms we can take 1 common to reach this step. Now one should see over here that you have x plus 2 common and bring out x plus 2 out, and then what you are left with x plus 1. So our objective is achieved now. What we wanted to do is done. We have expressed our given quadratic polynomials as a product of two linear factors, okay, which in this case is x plus 2 into x plus 1, equal to 0. Now the process is quite simple. So we will say that product of two terms is equal to 0, so at least one of them has to be 0. So either one can say that x plus 1 is equal to 0, or we can say that x plus 2 is equal to 0. The first statement gives us that x is equal to minus 1 is a value, and the second one gives us that x is equal to minus 2. Okay, and these two values attained at the end are what your roots of this particular quadratic are. And now you can verify, when you put x is equal to minus 1 back in the equation from where we started, of course it is going to satisfy that particular equation. So when you put x as minus 1, you will get 0 equal to 0. So thus we conclude this, that our roots in this case are minus 1 and minus 2. These are your two roots. Okay, but there are many questions where this middle term factorization is actually quite difficult to do. I mean there are a few questions where it's literally impossible as in a given frame of time. If you are solving a question in board, it's not possible to do. So I'll just give you a very easy example to understand this. Okay, so if I'm saying that, let's say if I have a quadratic like this, root 7x square minus root 3 plus root 5x plus 2 root 7. Now it would take us a lot of time to think how to split this middle term so that you can create these two product of a and c, that is the coefficient of x square and the constant. So there exists another way to solve this, okay, and that is the quadratic formula. So the root of any quadratic expression ax square plus bx plus c equal to 0 can be collectively be given by, okay, so let's say the alpha beta are the roots of the equation. Generally we take these two Greek letters, okay, alpha and beta to be the root. Okay, if there is a third root, if you are talking about a cubic, then we say alpha beta gamma, like this. Okay, so if alpha beta are roots of a quadratic, they are collectively given by this expression, minus b plus or minus root over b square minus 4ac divided by 2a. So if you know the quadratic, you know what the values of a, b, c are. All you have to do is input these values of a, b, c in this particular expression, do your calculation correctly, and then this particular equation will give you the value. Okay, so let's take that same equation and I'll just show it to you how to do it for that equation. So if this is the quadratic that we have, then the roots of this equation is going to be minus 3 plus or minus root over b square minus 4ac, so that is 9 minus 8 upon 2a. What is the value of a? It is 1. Compare, this is a, this is b, this is c. Okay, so that is 2 times 1, that will turn out to be minus 3 plus or minus 1 by 2, that will turn out to be minus 4 by 2 and minus 2 by 2. So that is, how do you get these two numbers? By taking plus sign once and by taking minus sign once. Okay, so for one of the roots you have to consider the plus sign in between, and the other root you will have to consider the minus one, and tada, you have your value. So your roots are minus 2 comma minus 1, the same numbers that we had formed using middle term factorization. Okay, now there are a lot of things that we can find out about a quadratic from this quadratic formula itself, but that would be dealt separately if we are discussing sometime later the chapter on quadratic equations. Okay, but as long as finding root of a quadratic polynomial is concerned, these two ways are sufficient. Okay, there exists a third way, a way that was devised recently, okay, but we are not going to go into that for now. Okay, I hope this point is clear. Okay, how to find roots of any quadratic polynomial. Okay, linear polynomial should also be understood and quadratic should also be understood. Okay, now the important thing to understand here is that because the roots in a way depend upon the coefficients. So if you go back and you just see, this formula for finding out root is nothing but a formula that contains the coefficients of the quadratic, right? It contains a, b, c. So as roots are dependent upon coefficients, now let us try to do the reverse process. Okay, now let us try to find a relationship between the coefficients and the roots. Okay, so given coefficient we can find roots. Okay, given roots, can we find any relation between coefficients? So this is what we are going to learn now. Now just, it's a very simple topic, and again this is something that is really important for your board exam. Okay, favorite of NCERT, they always ask a lot of questions on this. Okay, so for a linear equation of this type, ax plus b equal to 0, okay, we write the root as minus b by a. Okay, and notice here that b is nothing but the constant term, and a is nothing but the coefficient of x. So the root of a linear equation is negative of the constant term over there divided by the coefficient of x. Simply we can say so. Okay, and this is really easy to understand. I mean, this is a no-brainer actually, anybody can write this. So for example, 2x plus 3 equal to 0, root will be negative of the constant term, which is 3, divided by the coefficient of x, which is 2. Okay, now let's try to understand this relation for a quadratic expression. How does this behave for a quadratic? Okay, now let's say we have a general quadratic like this, ax square plus bx plus c equal to 0, and let us assume that the roots of this equation are some alpha comma beta. Okay, now there are two ways to understand this. Okay, that is relationship between the roots and the coefficients. One is using the quadratic formula. So we already know what the quadratic formula is. So we in a way know what alpha comma beta are. We know that alpha beta are minus b plus or minus root over b square minus 4ac divided by 2a. Take plus sign and call that root as alpha. So take plus sign and call it as alpha. So minus b plus root over b square minus 4ac upon 2a. Take minus sign and call that as beta. So that is minus b minus root over b square minus 4ac upon 2a. Now when you add these two expressions, your left hand side will become alpha plus beta. Now please notice, because your denominator is same, in right hand side this root wala part will cancel out and we will end up with this. Okay. Similarly, when you multiply, you will get terms like a square minus b square kind. Okay, I mean over here b square will cancel out and you will be left with 4ac by 4a square, which is nothing but c by a. So the sum of roots in terms of the coefficients of a quadratic is minus b by a, and the product of roots is c by a. Okay, and if you are looking closely, one must understand this now, that the sum of the roots here, can be written as negative of coefficient of x upon coefficient of x square, and the product of the root can be written as constant term divided by coefficient of x square. Very simple. Okay, and similar relationships exist for higher degree polynomials also. So there are for cubic, biquadratic and all higher degree polynomials as well. Okay, but the important part here is that we understand it for a quadratic. Okay, we'll be doing a question based on this also. So this was one way to understand this logic. Okay, the other way to understand it is going to be, the other way to understand the same thing will be, so we are going to make use of factor theorem. Okay, we are going to make use of factor theorem. So we all know that if alpha and beta are roots of a quadratic, then x minus alpha and x minus beta will be factor. So factor theorem is taught in class 9th. I hope you people have studied it. Okay, so if this quadratic has two roots alpha comma beta namely, so this would imply that x minus alpha is a factor and x minus beta is a factor. Okay, so of course once I can write this expression as something like this. Okay, but one has to be careful here, that are these two both expressions same? Now they will be same if the coefficient of x square on left hand side is also 1. Okay, because if you open up your right hand side, can you just visualize when x and x gets multiplied, we are going to get x square. Okay, but left hand side I have an ax square, so they do not look same. Okay, now this thing can simply be taken care by putting a in front of this. So when you put a over here, now we can be assured about the fact that yes, now these two expressions are same. Okay, because x minus alpha is a factor, so of course you can write it as x minus alpha into x minus beta over here, and now we are done. Okay, now simply take a common a common from this expression. You will get x square plus b by a times x plus c by a, and right hand side becomes a times x square minus alpha plus beta times x plus alpha beta. And because a cannot be 0, obviously if it is a quadratic polynomial, a cannot be 0. The leading coefficient, the coefficient of the highest degree term can never ever be 0. Okay, so a and a gets cancelled out, and we get that alpha plus beta is equal to minus b by a. How you equate the coefficient of x here to the coefficient of x here, that gives you alpha plus beta to be minus b by a, and finally the product alpha beta will be equal to c by a. So this is another way to see how the relationship between the roots and the coefficients of a quadratic is taken care of. Okay, now a very important consequence of this concept, like again something on which you can surely expect a question in your board exams, is this, that how do we write a quadratic in terms of its roots? So if a quadratic is known, finding root is easy. If the roots are known, how do you write the quadratic? So very simple, if alpha beta are roots, one way to write it is like this: some constant times x minus alpha into x minus beta. Okay, why are we including a constant here? Because you must understand that a quadratic having roots as 1, 2 is not a unique quadratic. There can be infinite quadratics which will have root as 1, 2, and if you want, I can just show you. For example, 1 into x minus 1 into x minus 2 equal to 0 is a quadratic which will have root as 1, 2. 2 into x minus 1 into x minus 2 is a quadratic that will have its root as 1, 2. Like this, I can put any number in front of x minus 1 and x minus 2. The roots are not going to change. Okay, so to include all such quadratics, we just simply put a k over here and we are done. Okay, or you can write this same expression. So this can again be written like this. Okay, so you can treat it as k times x square minus sum of roots into x plus product of roots equal to 0. Okay, now whenever we have to form a quadratic having some particular roots, how are you going to do it? Some constant times x square minus sx plus p, where what does s mean? S means the sum, p means the product, and as long as you remember this, the questions are really easy to solve. Now let's solve two questions based on this idea. Okay, now these are important. Okay, now here we say that if alpha beta are the roots of this quadratic expression, x square plus x plus 1, then we have to form a quadratic equation having its root as alpha square beta comma beta square alpha and alpha square by beta comma beta square by alpha. So let's start. Okay, let's start with the first part. So any quadratic having roots as alpha square beta comma beta square alpha, how can we write it? That can simply be written as k times x square minus sum of the roots. Now in this case you want the roots to be these two numbers, which is alpha square beta and beta square alpha. So I will write the sum of these two numbers, alpha square beta plus beta square alpha times x plus the product of roots. So product of roots here will be alpha square beta into beta square alpha, and how do you write that? That will become alpha cube beta cube equal to 0. But of course we cannot leave our answer in terms of alpha beta, so some way we must be able to attain a value for these two. For that we will take help of this given quadratic. Now notice, because alpha beta roots of this quadratic, we can write sum of roots is minus b by a. So minus b by a will become minus of 1 by 1, which is minus 1, and c by a. So product of roots is c by a, so that will be 1 upon 1, which is 1. Once you have done this, now the question is solved. Okay, now go back to this expression. Now here what we can write, k times x square minus alpha beta times alpha plus beta. So taking alpha beta common out of alpha square beta and beta square alpha. Okay, now all of this you will have to visualize. Okay, now there is no theory to be taught here. Okay, this is alpha beta ka cube equal to 0. Now that will give us k times x square. Now substitute the values that you have got. So alpha beta we have got as 1, alpha plus beta we have got as minus 1 times x plus alpha beta ka cube, so that is 1 ka cube, so 1 cube is equal to 0, or we get k times x square plus x plus 1 is equal to 0, and this is a quadratic equation whose roots will be alpha square beta, beta square alpha, provided alpha beta are the roots of this particular equation. I hope this should be understood. Okay, relatively simple example. As long as you remember that any quadratic having roots as alpha beta is x square minus sum of roots into x plus product of roots. Okay, now no matter what expressions we get, you will always be able to form this. Okay, next let's go to the second one. Okay, second one will be a bit lengthier to solve. Okay, so let's start that. Let's say we have to form a quadratic now whose roots are alpha square by beta comma beta square by alpha. So one can write it as some k times x square minus sum of roots, so that would be alpha square by beta plus beta square by alpha times x plus the product of roots, so that is alpha square by beta into beta square by alpha, and this is equal to 0. Again k times x square minus, so here you are going to end up with alpha cube plus beta cube upon alpha beta times x plus alpha beta after cancellation. So this alpha square will get cancelled by this alpha and beta square will get cancelled by this beta. This is equal to 0. Now alpha beta ka value is already known. How? We just discussed alpha beta is 1. So let me write it here for you. Alpha beta is minus 1 and alpha beta is 1. But there is a problem here that we need to figure out what is alpha cube plus beta cube. Okay, now how to do that? Now just notice. So some way you must be able to create alpha cube plus beta cube using these two relations only, that is alpha plus beta and alpha beta. How do you do it? You take this expression and you cube it. Okay, so the moment you cube that expression, what you will end up with is, so cubing both sides, we will get alpha cube plus beta cube plus 3 alpha beta into alpha plus beta, and that is equal to minus 1. Okay, now please again have a look at this expression. What is this? This is alpha beta and alpha plus beta, right? So we can substitute the known values. We already know what alpha plus beta is and what alpha beta is, so please do that. So and then you will get alpha cube plus beta cube is equal to minus 1 minus, taking this to the other side, 3 times alpha beta. How much is that? 1. How much is alpha plus beta? Minus 1. And this will turn out to be minus 1 plus 3, and that is 2. Hence we can write this as k times x square minus 2 by 1 times x plus 1 equal to 0. That will give us k times x square minus 2x plus 1 equal to 0. And this is the quadratic equation having its root as alpha square by beta comma beta square by alpha. I hope this question should be clear. Okay, again important point is x square minus sx plus p, and if your manipulation skills are good, pakka you will end up with the correct answer. Okay, so just practice questions based on this concept. There are a number of questions in NCERT itself. Do practice them and make sure that you are getting those questions. Okay, now, and these are types of questions that I mean even you can encounter in NTSE as well. Okay, now the last topic for today. Okay, so we are going to talk about graph of a polynomial. Okay, first thing to understand that what do we mean by a graph. Okay, now see, by now I guess every student studying in class 10th must have been introduced to the Cartesian coordinate system. Okay, so it is a system that contains two perpendicular lines like this. One we call as x-axis, the other we call as y-axis, and what do we do on this? We plot ordered pairs of points x comma y, right? Now please realize this, that given a polynomial, so when you have a polynomial like this, okay, let me call p of x as a polynomial. Now when you put an input value in p of x, that does give you an output which we are representing as y. So we can say that when I know a polynomial, for every x there is going to be a y. Whatever x I put inside a polynomial, that will give me an output. So we have a lot of pairs of x comma y's based on any polynomial that you have. Okay, so when you plot all those values, okay, and I'm going to do it for a linear and a quadratic and show it to you how it's done. Okay, for right now just understand the theory. When you plot all these values of x comma y on a graph sheet that contains your x and y axis, you are going to create a picture. Okay, some picture. For example, let's say this is 1x comma y, this is 1x comma y, this here is 1x comma y, this is 1x comma y. When you connect all these like this, So the picture that we create on the graph sheet, this is what we mean by a graph of a polynomial. Okay. Now, so graphically, the roots of a polynomial are the values of x for which the graph intersects the x-axis. Again, if you have a sound knowledge of coordinate geometry, you must be knowing by now. Let me just tell you one thing. You must be knowing by now that everywhere on the x-axis, the value of y is 0. This is again something that is very, very basic. Everywhere on the x-axis, the value of y is 0. Right? Okay. So when you draw a polynomial, let's say this is how a polynomial looks like. Okay, let us focus our attention to this value of the polynomial. Okay, the one that I am telling you now. Let me change the color. Okay, let's say this green dot. Okay, this green dot I have put over here. Okay, let's talk about that value of x. Okay, so one can say that is a value of x where the graph of this polynomial is intersecting the x-axis. Okay. So that means that is a polynomial, that is a value of x that is there on both x-axis and the polynomial. Now any value on the x-axis, there y is 0. Okay, so that means for the polynomial also, at that chosen value of x, y is 0. And when is value of y equal to 0 for a polynomial? When is output of a polynomial equal to 0? At its roots, right? So it should be understood that whenever a polynomial intersects the x-axis, the points of intersection are nothing but the roots of the polynomial. Okay, one more time. When a polynomial intersects the x-axis, those are the points which lie on x-axis as well as polynomials. And we know that any point on x-axis means that y is 0. Now, if y is 0, then with respect to polynomial, it means that has to be a root. Okay, because y equal to 0 is only true for a root of a polynomial. Okay, I hope this point is clear what we mean by a polynomial and what do these points of intersection mean. And of course this value over here, the one that I have just told, that is a value of y obtained for x equal to 0. Now if you have a clear idea of graph, you will understand all the things that I just talked about. Okay, now this concept is important because you do get a lot of questions in your board exam based on this. So for example, they will ask you a question like this. There is a polynomial that goes like this. How many roots are there? So the number of times. So we will just say that, oh, this is one point. Let's call this x1, or let's call this alpha. This is one point. Let's call this beta. This is one point. Let's call this gamma. These are 3 points for which the graph of the polynomial is intersecting the x-axis. So there are 3 roots in this case. Okay. So in a way, looking at a graph, if we have to decide how many roots are there for a polynomial, you just have to count the points of intersections of the polynomial and the x-axis. How many times is the polynomial cutting your x-axis? If it cuts 3 times, 3 roots. If it cuts 10 times, 10 roots, and so on. Okay. Now, if we discuss this, that what do the graphs of some basic polynomials look like? Okay. Now graph of a linear polynomial is always a straight line. Okay, so you are going to get a straight line drawn on your xy axis if you are plotting a linear polynomial. Okay, and I'm going to do one for you and just try to understand how do we actually plot a graph over here. Okay, so you see I have taken a polynomial which our case is 2x minus 3, and here I have taken a graph sheet where we are going to plot these values. Okay, now obviously when you have to plot, you need to choose a few inputs and few outputs, right? So p of x is what is y. Understand the notation again. Okay, y is nothing but output values, so we are calling p of x equal to y, because when you put as x as input, if you put x as 1 equal to input, then p of 1 is the output straight away. Okay, so y is equal to 2x minus 3. Okay, let me form a table over here, a very small table, where we are going to choose a few values of x on our own. Okay, any value you can choose. Okay, let's say we select x to be 0, 1, 2, 3 and 4, and let's calculate the values of y for these chosen values. So when x is 0, you put x as 0 in this expression, you get y as minus 3. 2 times 0 minus 3. When x is 1, this will turn out to be minus 1. When x is 2, this will turn out to be 1. When x is 3, this will turn out to be 3. And when x is 4, then this will be 5. Okay, now we say that the points 0 comma minus 3, 1 comma minus 1, always x is written first, y is written next. 1 comma minus 1, 2 comma 1, 3 comma 3 and 4 comma 5, these are all points that will lie on the graph of the line. Okay, these are all points that will lie on the graph of the line, or in other words, our required polynomial, which will be a straight line, will pass through these points. Okay, so on this graph sheet, let's identify this. So x0 and y minus 3 is nothing but this green dot over here. Okay, x1 and y minus 1 is this dot over here. x2 y1 is this point. x3 y3 is this point. x4 y5 is this point. Okay, now if you connect all these, you can see that you're getting a straight line, and this is the graph of y is equal to 2x minus 3. Okay, so I hope it should be clear what a graph of a polynomial means, and in particular how do we draw a graph of a linear polynomial. Okay, and again, a single polynomial is going to have a unique graph. So either I give you a graph or I give you the equation, both are interchangeable. I mean, given a graph, you should be able to decide of which polynomial this graph is, and given the polynomial, we must be in a condition to draw the graph of the polynomial. So this should be clear, people. Okay, and this is really easy to understand as well. Okay, now let's understand the graph of a quadratic polynomial. Okay, and before we move ahead, some pretext on what we are going to do. Okay, now graph of a quadratic polynomial, when you draw it, by nature this comes out to be a parabola. Okay, so a parabola is a shape that actually looks like this. It's kind of a bucket shape. Okay, open on two ends and close on the other. Okay, so if you see, we say this is an upward opening parabola because it's open in the upward direction. Okay, and it continues like that. Okay, so it's an upward opening parabola, and this is a downward opening parabola. This is a downward opening parabola. Okay, now a quadratic can have either of these two graphs. It can be upward opening, it can be downward opening. Okay, what decides it? So we are going to talk that. Okay, what are the kinds of quadratic whose graph can be upward opening? Which quadratic will have a graph downward opening? Okay, if a quadratic has real roots, how will the graph look? If it doesn't have real roots, then how will the graph look? So follow really closely now. Okay, because what we are going to do now is important, and if you miss any detail, you might have problem in understanding. Okay, now, so if you see in this picture that I have drawn over here, so let's say I'm talking about a quadratic polynomial, which is this ax square plus bx plus c. So this is a quadratic polynomial which we are calling as p of x, or p of x on y are the same thing. Okay, so y is equal to p of x, and that is ax square plus bx plus c. Now in three pictures that you see, each of these parabolas are upward opening. Okay, reason being, for all these parabolas, a is greater than 0. That is, if the coefficient of x square is positive, then the graph of a parabola or the graph of a quadratic will always be an upward opening parabola. Okay, and you have to keep this in mind. Upward opening parabola will occur if and only if the coefficient of x square is positive. Okay, now you see that there are three distinctions over here. There is one where we see that our parabola is intersecting the x-axis at 2 points. There is one where we see that our parabola is just touching the x-axis and going. There is one where we see that there is no contact between the x-axis and the parabola, no contact at all. Now we have already discussed that wherever the polynomial intersects the x-axis, those values of x are your roots. Okay, so the first picture actually tells us that this parabola has two real roots, or this quadratic has two real roots. Okay, the next one tells us that this also has two. See, for a quadratic we never say that a quadratic has one root. Okay, but the language that we use here is that here there are two real roots which are coincident. That means both are same in value. For example, you can say that this can be a graph of x minus 1 ka whole square. Okay, so x minus 1 ka whole square is a quadratic. It is x square minus 2x plus 1. So the second graph is also the graph of a quadratic only, but here we say that the roots are repeated roots, or the roots are coincident, so they are same, 1 comma 1, 2 comma 2. So it is a perfect square, something like x minus 2 square, x minus 3 square, and so on. The last one, here we will say that there are no real roots because the graph doesn't intersect with the x-axis at all. There is no point of intersection between the graph and the x-axis, So we will conclude that there are no real roots in this particular case. Okay. Another important point to understand is that based on whether there are two real roots, we can talk about the discriminant of the quadratic. This is something that is beyond the scope of polynomials, but because I am discussing about graphs, so I will just talk 2 minutes about this also. Okay. So two real roots itself implies that the discriminant, which is b square minus 4ac of a quadratic, would have been positive. So one can say if a is positive and discriminant is positive, the quadratic will intersect the x-axis twice. And please don't get confused by the fact that, sir, why did you take one negative, one positive? These 2 points of intersection could be anywhere on the x-axis. Okay, it could have been here, it could have been here, it can be anywhere. Okay, but I had to take it somewhere, so I have taken it the way you see it on the screen. Okay, so kindly do not confuse yourself with all of this. Okay, next is over here, because there is only a single root, or we will say coincident roots. Okay, roots are repeated. We know when that happens. Okay, that happens when the discriminant, sorry, okay, we know that will happen. Wait 1 minute, people. Okay, just a moment, some issue. So that is going to happen if b square minus 4ac is equal to 0. That means when the quadratic has discriminant equal to 0, then the graph will just simply touch your x-axis and then go. Okay. And lastly, in this particular case, because there are no real roots, so we know what follows from there, that b square minus 4ac is going to be less than 0. That means the discriminant of this quadratic will be negative number. Okay. So if we know about the leading coefficient, if we know about the discriminant, you can actually draw the graph of any quadratic. Okay, instead, if just simply knowing the quadratic equation, you can draw the graph, and from the graph we can deduce a lot of things, whether the quadratic discriminant was positive, negative, and so on. Okay, and since we are talking about this, just one slight more detail I would like to add. In all these three expressions, you might be able to see that over here, everywhere there is a lowest point that the graph of this quadratic achieves. Lowest point. That means if I talk, let's say this value here. Okay, let's say this value is minus 5. Here this value of course is y equal to 0. Let's say here this value is 2. Okay. Now in the first case, the graph simply doesn't go below minus 5. In the second case, the graph doesn't go below y equal to 0. And in the third case, the graph doesn't go below y is equal to 2. So a quadratic whose a is positive, okay, will always have a minimum value attached to it. There will always be a minimum value to it. Okay, so yes, there will always be a minimum value attached to it. So that means there will be a value of y below which the quadratic cannot go. Okay, now we are going to discuss when this minimum occurs and what is the value of this minimum. Okay, so this is again very easy to understand. Okay, I'm not going to derive this because that will be a time taking process, but do remember this. If any of you are appearing for NTSE, this is going to help you. Okay, now the value of x for which this minimum occurs. See, if a minimum y is being attained, it will be attained for some x, right? Okay, so this value of x for which this minimum is attained is minus b by 2a, and this minimum value attained over here, this is equal to d by, so this is minus d by 4a, or you can write it like this, it is 4ac minus b square upon 4a. Okay, so what is the minimum value? It is minus d by 4a. D is the discriminant. I hope you people know it. By d I mean b square minus 4ac. Okay, so the coordinates of this particular point on the graph is minus b by 2a comma minus d by 4a. Similarly, here also it is attained at minus b by 2a comma minus d by 4a, and because d is 0 there, so the minimum value is 0. And here the minimum value, again, where does it occur? At minus b by 2a. What is the minimum value? So this is minus d by 4a, and because d is negative here, so we can see the minimum value is positive. Okay, so do remember this. Okay, and this is called as the vertex of the parabola. In each of these cases, if this, we call it as the vertex of the parabola. This is not required for boards. This is not required for boards. Just extra we are learning. Okay. Or we also say turning point. Turning point. Okay. Okay. So I think this point should be clear. Okay. Next, and the last point now that we are going to discuss. Okay. Now here you see that there are three graphs which are downward opening. So obviously this will be true for a less than 0. Come to the first graph, you see that there are 2 points of intersection. So there are two roots. So here I can say a less than 0, d greater than 0, that is discriminant is positive. In this case I can say a less than 0 and d equal to 0 because here there is a repeated root. The graph simply touches the x-axis, turns back and keep on going. Here we can say a less than 0 and d less than 0 because the graph never ever crosses the x-axis. So no roots at all. Okay. Again, in these cases one can say that there is a maximum value that these graphs are attaining. There is a value over here on y-axis above which the graph doesn't go. Okay. In the previous case it was below, here it is above. Here again there is a value above which the graph doesn't go. Okay. Here again there is a value above which the graph doesn't go. Again these are the vertex of the parabola or the turning point. Okay. What are these coordinates? What is the x coordinate? What is the y coordinate? Same. Okay. Ditto same. Where does it occur? X is equal to minus b by 2a. How much is this value? Minus d by 4a. Where does this occur? X is equal to minus b by 2a. How much is this value? Minus d by 4a. In this case d is 0, so we can say it is 0. Where does this occur? X is equal to minus b by 2a. What is this value? Minus d by 4a. Okay. So this is how you actually express the maximum and minimum values of a quadratic expression. Okay. I hope whatever was taught is understood. We are not doing questions based on these. Okay. Though if somebody is preparing for NTSC and all, do solve questions based on this topic on your own. Okay. I hope polynomials is clear to you, what we mean by polynomials. Okay. Thank you for listening to this lecture. I hope this serves you well. Okay, bye bye everyone, take care of yourself till we meet for the next time. And in case if you have any kind of doubt, you can leave it in the comment box. Okay, and do keep visiting this channel for new videos, for videos that are well explained, for videos that are detailed, and you are not going to be disappointed. Okay, thank you everyone, thanks.